Hey there guys, welcome to the video. My name is Pushpinder Gill and today we're going to be talking about Bayes theorem. So suppose you've already watched all our probability videos like the simple probability video, the conditional probability video. In this video we're going to be talking about the Bayes theorem. Now before we do that, just to let you know that this is a website that is perfect dashcourse.com. Just go ahead and visit it to explore more about us, and this would be our Facebook page to give us your valuable like. And if you have any feedback, you can always give at perfectscores89@gmail.com. So let's go ahead and get started, guys. So before I start with Bayes theorem, I'd actually like to start with the concept of total probability. So let's suppose if I say that this is my whole universe and there is an event A right here, right? There is an event A right here and I want to find out the probability of event A happening. And I do not have the probability of event A directly, but there are so many events that will actually overlap with event A. Let's suppose that event is event E1. Another event is, let's suppose, event E2. Another event is, let's suppose, E3, and so on. And these events do not overlap with each other, and we have a total of En events. Now I have so many events and I want to find out the probability of event A happening. Well, that would be equal to the probability such that event E1 occurs into the probability such that event A occurs provided E1 has already occurred, plus the probability that event E2 has occurred into the probability such that event A occurs provided that E2 has already occurred, plus the probability of event E3, and so on till the probability such that event En occurs into the probability that event A occurs such that En has already occurred. Now why have I done that? Now in some questions you're not given the straightaway probability. You're not given what is the probability that event A is going to happen. Instead you're given the reverse probability, or you're given the conditional probability. Sometimes, let's suppose if I want to start with an example, right? Let's suppose I say that there are two bags, bag A and bag B. This has 5 red balls and this has 6 green balls. This has 4 red balls and 3 green balls. I say, what is the probability of getting that ball, getting a ball from bag A such that the ball that I've got is a red ball. So what I'm doing is I'm actually going back. I know that the ball that I've got is a red ball and I want to find out the probability such that the ball belongs to bag A. So over here I will actually be using this here, that probability of event A happening is equal to the sum of all the possibilities happening here. So probability, we're going to actually do a question on this right now, but I suppose everyone is understanding what I'm trying to say here. That is, the total probability is actually equal to the sum of all the individual probabilities and all the conditional probabilities here. Let's just pick up a question. Okay, so the question here is that John has taken up a job. The probability of a strike is 0.65. So the probability that is going to be a strike is 0.65. And the probability of completing the job such that there is no strike is 0.8. So probability of completing the job such that there is no strike is equal to 0.8. And we know that if probability of strike is 0.65, probability of no strike will be equal to 1 minus 0.65, which will be equal to 0.35. And question further says that the probability of completing the job, so the probability of completing the job such that there is no strike, such that there is a strike, is equal to 0.32. And the question is asking what is the probability of completing the job on time. So probability of completing the job on time, actually there are two aspects. So if I say that this is the whole universe and this is me completing the job, it is actually bolded into two parts. If there is a strike, if there is no strike. So probability of completing a job will be equal to probability of strike happening into probability such that I complete the job provided strike has happened, plus probability of strike not happening into probability of completing the job such that there is no strike. So this will actually give me the probability of completing the job, right? Because this component right here tells me probability of completing the job provided the strike happens, and this component over here multiplies, this component over here multiplies with the probability of strike happening. And this over here probability of no strike happening into probability of completing the job provided that there is no strike. So if I kind of fill this up now, so probability of strike happening is going to be 0.65 into probability of this, into this is going to be 0.32 plus no strike is 0.35 into no strike is 0.8. So that is actually going to be my answer, right? So, I suppose you're understanding my point over here. So yeah, so that will actually, if I calculate this, this is going to come down to as 0.488. Right. So, keeping the calculation aside, I suppose you're understanding what I'm trying to do here is that if you're not given the complete probabilities, you're instead given the conditional probabilities, and you know that this event C is actually comprises of two sub events. If there is a strike and there is no strike. Now these events are not independent events, because completion of the job, it will actually depend on strike, or it will actually depend on no strike. So this event, the probability of this event actually depends upon me having strike or no strike. So that means these are dependent events, and in that case I will actually have to use this. Now that is just the theorem of total probability. Let's actually define Bayes' theorem here. Now what does Bayes' theorem tell you? I'm going to put that here and explain that to you. Bayes' theorem says that if, again, let's suppose if I say there is an event A which is actually divided into so many different events, such that the probabilities of event A is happening such that these events happen, they're different. So that means A is actually dependent upon these events to occur, and I say I want to find out the probability of event A happening such that, okay, so let's talk about probability of event A occurring. That would be equal to probability of event E1 occurring into probability of event A occurring such that E1 occurs, and so on till probability of En occurring into probability of A such that En occurs. Now that is the total probability of event A occurring. Now let's suppose if I want to find out something reverse. I actually want to find out what is the probability such that one of these event E occurs. Let's suppose we want to find out the ith term. We want to find out what is the probability such that one of the event eth occurs such that A has already occurred. That would be equal to, let's suppose I want to find out for this one part. So that would be equal to this probability divided by the total probability. So this probability would be probability of E of I. So it can be 1, 2, 3, 4, 5, 6, whichever it is, into probability of A over E of I, which is this component, divided by the total probability, divided by the probability of event A occurring. Because we've been told that event A has actually occurred. If I say that event A has actually occurred, what is the probability of event EI occurring? Then this is going to be our probability. Now this is something which can also be written as probability of EI into probability of A by EI divided by the summation of, so this actually can be written as the summation of, you can clearly see here that is that can clearly be written as j equal to 1 and j till n probability of E of j into probability of A by E of j. I'm just writing this whole thing as a summation here. Now I know there will be a lot of questions in your mind. Let me clear that. Bear with me, let me clear that with an example here. Okay, so this question says that bag A contains, so you have bag A. Bag A contains 3 red balls and it contains 4 black balls. Bag B contains 5 red balls and 6 black balls. Now over here, the question says that one ball, so the question is saying one ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag B. Now we are actually talking about bags here. So what is the probability of choosing bag A? That is actually equal to half. What is probability of choosing bag B? That is actually equal to half again. Now, what is the probability? What is the probability of choosing bag A, right? And then choosing a red ball from bag A. Okay, not that, not that. What is the probability of choosing a red ball such that bag A has already been chosen? So what is the probability of choosing a red ball such that bag A has already been chosen? That is actually equal to 3/7. And what is the probability of choosing a red ball such that bag B has already been chosen? That will actually be equal to 5/11 from here. Now the question is asking, find the probability that it was from bag B. Right, so we have to find the probability that the red ball was actually drawn from bag B. So the probability such that the ball is red, right? So what the probability such that it was bag B provided the ball was red will be equal to, now if I apply Bayes' theorem here, that will actually be equal to, I'll calculate for this probability, which would be equal to probability such that it was bag B into the probability of choosing the probability of choosing the red ball from bag B divided by the total probability. What's the total probability? That would be the probability such that it's bag B into the probability of red ball provided it's bag B plus the probability that it was bag A into the probability such that it was red ball from bag A. Right, so you can clearly see this is something which is matching this over here, such that probability such that the back event occurs provided the event has already occurred is equal to the probability of that event occurring divided by the total probability. So if I calculate this here now, that would be equal to probability of event B occurring. So probability of a black bag is 1/2, that is 0.5 into R such that it's B, which is equal to 5/11, divided by probability of choosing bag B, which is again 0.5 into probability of this, which is again 5/11 plus 0.5 into that is going to be red of A, that is 3/7. So that is going to be my answer. So I'll just explain this once again. We were asked find the probability that the ball was from bag B. So we have to find the probability that it was from bag B provided we have chosen a red ball. That would be equal to choosing the bag B into probability of getting the red ball from bag B divided by the total probability. Right? So suppose you're understanding this here. Let's do another question so that things become much more clearer. There are 3 identical boxes A, B and C with 2 coins each. Box A contains, so you have box A, it contains 2 gold coins, and box B, so let me say GG, box B contains 2 silver coins, and box C contains 1 gold and 1 silver coin. So Henry chooses a box at random and takes out 1 coin. If that coin is gold, what is the probability that the other coin in the box is also gold? So we have to find out the probability, because there's just one bag which has 2 gold coins. So we have to find out what is the probability that it was box A. So what is the probability that it was box A such that I get gold on the first case, right? Because I've already gotten a gold. Right, such that I've already gotten a gold. So this is what I'm supposed to find out. So that will actually be equal to the probability of getting bag A into the probability of choosing gold provided it's bag A, right, divided by, so that now we'll have to do the total probability of choosing bag A into probability of choosing gold such that it's bag A plus probability of choosing bag B into probability of choosing gold such that it's bag B plus probability of bag C into probability of choosing gold such that it's bag C. So that would be equal to probability of bag A. What's the probability of choosing bag A? Because there are 3 bags. So the probability is 1 by 3 into probability of gold such that it is from bag A. What is the probability of choosing gold from bag A? 1, because there are only gold coins in bag A, divided by probability of choosing bag A, which is again 1 by 3 into the same thing, that is 1, plus what is the probability of choosing bag B? 1 by 3 into what is the probability of choosing gold from bag B? 0, because there's no gold in bag B, into probability of choosing bag C into the probability of choosing gold from bag C, that is half, because there is 1 gold and 1 silver coin in the bag. So that is actually going to be our answer here. So I'll repeat what I just did here. We were supposed to find, we've already gotten gold from first bag, and let's call it G1. What is the probability that it will be from bag A? That would be equal to getting the bag A into probability of gold such that we've already gotten the bag A divided by the total probability, right? So that is actually equal to our total probability here. Let's go ahead and do another question. Now this question over here says that of people having a disease, 90% of the test detect the disease, but 10% 90% of the tests detect the disease and 10% go undetected. So the people, they are having some tests, and the test is able to detect 90% of them. So the test is able to detect 90% of them, and the 10% go undetected. And of the people not having the disease, 99% are actually not detected, and 1% are diagnosed as positive. So the question says the probability that only 0.1% have the disease and 1% is selected at random, given the test, and report him positive. What is the probability that the person actually has the disease? Now we are supposed to find the probability that the person actually has the disease. So the probability that the person has the disease, which means he actually has the disease, provided he has been tested positive, because he says 1% is selected at random given the test, and the report is positive, report him as positive. So provided that the person is positive. So that would be equal to the probability of having the disease into the probability of person being tested positive provided he has the disease, right? Because in this case over here, if I talk about the whole sample space, we have the person having the disease. Now person can actually have the disease when he's tested positive and when he's tested negative, right? So these are the only 2 cases here, and we are supposed to find what is the probability that person actually has the disease. So we are supposed to find the probability that person has the disease provided he's positive. That would be equal to the probability that person has the disease provided he's positive divided by the total probability, which would be equal to probability that the person has the disease provided the person is positive provided he had the disease, plus the probability that the person does not have the disease, no disease, into the probabilities that the person is tested positive provided he does not have the disease. Now this has to remain constant because this is something that has already happened. The person is tested positive. So this will remain always as true because this is the sample space. So that is going to be equal to provided probability of person having the disease. So what is the probability that the person is going to have disease? That is 0.1%. So let's call this at 0.001 because it's 1%, so it's going to be divided by 100 into the probability of person being positive provided the person has the disease, right? So that will actually be equal to 90%, that is 0.9, because let's call it 90% is 0.9 only. So 90% of the tests detect the disease. So if the person is having the disease, 90% of the times he will be detected. So that is actually equal to 0.9 divided by the probability of person having the disease, which is again 0.001 into again 0.9 plus the probability of the person not having the disease, which is actually equal to 0.1 minus 0.001, which is 0.999 into the probability such that the person is tested positive provided he does not have the disease. So of people not having the disease, he has to be tested positive, which is only 1%, that is actually equal to 0.01. So in that case, if we calculate this equal to, this is nothing but 90 divided by, this is 999 plus, 90, which is going to be 1089. So this is approximately equal to 0.083. The calculations doesn't matter. What matters is this, right? So I suppose you're understanding this point over here, guys. Let's do one more question so that it becomes more clear to you. Now let's go ahead and do this question. So the question says that David speaks truth 3 out of 4 times. So the question says that he throws a die and reports a 6. So find the probability that it is actually a 6. So let's try to find the probability. So the probability that he reports 6. So probability that he reports 6 such that it is actually a 6 is going to be equal to 3 by 4. Because that's the probability of him speaking the truth. Probability that he reports 6 such that it is actually a 6 is actually equal to 3 by 4. Probability that he reports 6, because we know that he's already reported 6. Now this is something which is a fact, which is true. So we know that he has actually reported 6. So the probability that he reports 6, provided that it is not 6, is actually equal to 1 by 4. Now the question is asking us, what is the probability that he reports that it's actually a 6, provided he has reported 6. So this is something that we are supposed to find out. Supposed to find out the probability such that he reports, such that it is actually a 6, provided that he reports 6. So that would be equal to the probability of a 6 into the probability of, this is gonna get reversed, I suppose now you know the drill, divided by the probability of reporting having a 6 into probability of him reporting, provided it is a 6, plus probability of not having a 6 into probability of him reporting a 6 such that this is not a 6. And he's actually reporting a 6, that's a fact. So that has to remain a fact here. So that will be equal to probability of a 6, which is 1 by 6, into probability of him reporting a 6 such that it is a 6, that is actually equal to 3 by 4, divided by probability of a 6, which is actually equal to 1 by 6, into probability of him reporting the 6 such that it is a 6, that is again 3 by 4, plus probability of not having a 6, that is actually equal to 5 by 6, into probability of him reporting a 6 such that is not a 6, that is actually equal to 1 by 4. So that is actually being that will actually be the answer. So suppose you're understanding this point over here, guys. This is the Bayes theorem, and if you're able to understand this, you'll be able to solve any question on Bayes theorem. Just understand that. I'll just reiterate what I just said. This is the whole universe, and this is an event A, and these are the individual events, which kind of make up A. And if you're supposed to find out what is the probability that this individual event ith occurs, provided A has already occurred, that would be equal to probability of this individual occurring into probability of A occurring provided the individual occurs, divided by the total probability, which would be equal to the sum of all the possible probabilities there. Right? So I suppose you're understanding this point over here, guys. And thank you very much for watching this video. And this would be our website address, that is perfect-scores.com. Don't forget to explore this. You can ask me questions, you can practice here, you can do a lot of things. This would be the Facebook page to give us your valuable like, and this would be our email address to give me your feedback. So this would be about this video, guys. Thank you very much for watching. I suppose this helped you. I'll see you in the next one.